Welcome back, everyone. Today we're going to go over the installation of the fish tank and some of the plumbing. These videos are brought to you in part by our Patreon contributors. Our top contributors are TrueAquaponics.com, GreenLifePlanet.net, GlassBottleOutlet.com, and GrowPockets.com. Thanks for your support. The first thing I'm going to do on this tank is install the window, so I've marked out my spot where I want it to go. I'm going to put it in now and let the silicone gasket set up in place, and then I can go and work on the rest of the plumbing on it while this is getting set up. Now I've already figured out where I want to set the first hole, and I'm going to use the window as a template for the other holes. I've already pre-drilled all the holes 2 inches apart and 1 inch from the outer edge of the window. And I also rounded over all the corners so that on the inside the fish won't scrape against it if they're rubbing against it. Next up, we'll mount our window template from the inside. I like to put these 2 long carriage bolts through the middle ones. That way I can flex the polycarbonate window up against the tank. And that will help align all the other holes, and I can drill them through. Drill a couple more holes just to take out this last little bit of bowing between the tank and the window, and I'll anchor these down into place, and then I'll finish drilling the rest of the holes out. Now that it's all bolted in, we can go and finish drilling out the rest of the holes. Now that all the holes are drilled, I can take all the bolts out that was holding my window template in. And we're going to use a straight edge to draw a line where the window cutout's going to be. The easiest way I've found doing that around the curve is to put the bolts loosely into the holes like this, and then go around with the straight edge. I guess for that one, since it's straight, you don't need all the bolts. Just the beginning and the end one. Just clean up the edges a little bit here. A little bit of acetone to clean off my markers and just clean the high density polyethylene tank. Or maybe this is medium density. You don't want to use this on the polycarbonate window because it will etch it, but it is safe to use on the polyethylene. Forgot to hit record on the camera, but I basically added 2 beads of silicone around the perimeter of the window, and that will act as a sealant or a gasket between the window and the tank walls. And then we'll use my long bolts again to hold the window in place. I can pull it through and get the... Whoops. If you had an extra set of hands, you wouldn't need to use these long bolts. You just have somebody on the inside pushing the window into place while you have another person on the other side putting all the nuts and everything on. But one-man operations. Now that the window is more or less tight against the tank, I can just go and feed the rest of the bolts through their holes. So each bolt is a nice big pan head to help distribute some of the weight load around the window. And then there's this neoprene gasket that's used to seal the head to the window. And you have the tank in the middle, and on the outside of the tank there'll be this washer and of course the nut to hold it all together. This is definitely one of these jobs that'd be a little bit easier to have another person on the inside of the tank holding all these bolts into place. It's not impossible to do it alone, but it is a little bit more difficult. Now that I got these on each side of these long bolts in, I'm going to tighten it up a little bit and then remove these long bolts and put the proper bolts in. Now that all the bolts are in and loose, I can go and tighten up and take the gap out where the silicone needs to spread out a little bit. And without having a spotter on the inside of the tank, I'm actually using the monitor on my camera so I can see what I'm doing back there. Now, the trick is to tighten it up just enough so that the silicone will flatten out and also not bulge out the gasket on the behind the head of the bolt either. Alright, now that that's all tightened up, I'll let that set for a couple days and this tank will be ready for some water. So next up, I'm going to work on putting the drain line in that will go to the radial flow filter. And I'm going to set the center line of the pipe 8 inches below the top rim. The water level will be about 2 inches below that, so I'll have 6 inches roughly of head pressure to push the water up that pipe and then out. Should be just enough to get my flow just right. I was thinking about getting it a little bit lower, but down at 12 inches, I'm going to lose 4 inches of elevation if I run it into the radial flow filters that way, and I don't want to cut those down to be that small, so I'm going to take my chances and go up to my 8-inch center mark. This is an 1.5" bulkhead fitting. A lot of people will ask why I didn't put in uni seals instead of the bulkhead fitting, and it's really a personal preference. I like the bulkhead fittings. Mechanical bond with the rubber gasket on the back side, it really works well for making sure the water doesn't leak out. I can just hand tighten it. It's installed now, and then I can just use standard threaded fittings to put into this. So if I had to make a change, I don't have to remove the fitting from the tank. I can just unthread the piping that's going into it, and I'm all squared away. So this drain setup is using a solid lifting output, what most people just call slow, for sucking the solids off the bottom of the tank. So I took this 3" to 2" adapter and machined down some slots into the bottom of it with my table saw. And this will be used right along the bottom of the tank to suck any of the solids up into this pipe, but it's closed off enough where the fish won't get sucked through this setup. And you really want to open up the bottom of this, make it wider, so that you have more surface area, or more area for the water to go through without going through a small concentration. So it really helps to reduce the amount of suction power, so you don't get fish stuck right into the bottom of this opening. So from there it goes down to a 1.5" size piping. That's the pipe I decided to use. I like to go with 1.5" just to keep the water moving. I've seen some that are larger, and if you suck up a stone or something, a lot of times they'll just tumble in the pipe because you don't have enough velocity to keep that water going. So I bring it down to an 1.5", and that's usually enough to keep the water coming up. And then up at the top, there'll just be this 90-degree elbow, so the water comes this way, and there'll be a pipe continuing up to act as an air stop, so water flowing through doesn't create a siphon and siphon all the water out of the tank. Just put one of these gate valves on the outlet, so if I need to shut off the water to the rest of the system, do maintenance on the radial flow filter or something, I can easily do that right from here. The main outlet of the tank uses this overflow. It's similar to how a Cornell style tank would work, where it's essentially just skimming the cleaner water off of the system near the top of the tank. So that will have that like that. And then I took this piece, it's a 4" to 3" reducer, I'm using it sort of as a weir, and I machined out the taper in here so I can just slip it over this. And I'm going to put a screen over this. I'm just printing it out of my printer right now, so I'll get that on here in a couple of days. Now that the fish tank is ready for water, we can connect the deep water culture bed back up to the tank, get that ready to start circulating some water. So the whole system's designed where it could be plumbed above ground, but I'm going to run this one section just underground, just so it's not a tripping hazard. So what's going to happen is the water's going to come out of this bed here. There'll be this 3" T. It'll actually have a 1" reducer in here. That will get us to the pump. The pump has these couplings on there so it can be easily disconnected. And then it's going to pump through a 2" line just to minimize resistance in the line all the way back up to the tank. Now this is a temporary section because I just want to get the first bed up and running. Once the other beds are running, this whole pump system will come out. So I'm going to trench out this whole section and get it ready for the lines. Okay, so my trench is dug. It's a little bit wider through here because this is where the 3" line that interconnects the beds will go across the aisleway. Of course, with my luck, I hit this massive rock that is about 6 feet long. Fortunately, it's just low enough where I still be able to rest the pipe right on top of it and bury it, and I'll have about a 1/2 inch of sand on top of it. And since it's not in a walkway, I'm not overly concerned about it getting crushed or anything. So now I'm just going to spend a little time, put all these in, and backfill it in with sand. This end of the plumbing's all set. Comes out of the bed, goes into this nice little Awaki pump, and then heads underground. Comes back out on this side, and then heads down the greenhouse to return to the tanks. So I now have the line coming in from the deep water culture bed to this first tank. I'm going to do something a little non-conventional here by putting a valve in with a T. Now this T will also have a valve in it heading off to the other tank, and of course this will come up and drain water into this tank, but this line will feed to the other tank once I have the second line in, because this system runs on 2 pumps, one for each tank, and if there's a problem with one of the pumps, I can shut off that line, open up this valve, and the water will flow into both tanks. So I'll get half the flow going in the tanks, but I won't have a total catastrophe by not having any water running. So I'd rather have half the water running by moving a couple valves on, and then I can just do maintenance on the pumps and keep the system running. Alright, it's the moment of truth. I'm going to open up the valve, which will get water into the pump. These pumps should never run dry. They'll ruin the ceramic bearings that are in them. So we'll get that water flowing through there, turn on the pump, and see what happens out on the other side. I'm just going to plug this reducer in to shoot it into the tank. Also, once it's flowing, I want to measure the flow rate, because this will tell me if I size my pump properly. Alright, we're going to try that again. It shoots it out a little too fast, so I got another scrap pipe with an elbow in it so I can hold the bucket a little bit closer to myself. I couldn't hold the weight out with my arms fully extended with the 5 gallons in it. So I'll try this again. Alright, for those of you that are keeping track, this pump is drawing under load 295 watts, and it's pumping 20 gallons a minute, which is 1,200 gallons an hour. So that's enough to exchange the water in that tank once an hour. That comes out to be 4 watts per gallon per hour for your efficiency. Hi there, I wanted to jump into the future for a minute. That original commercial pump that I installed, I pulled that out. It was drawing about 300 watts, which is fine for commercial operations where you really don't care about the power consumption. That pump would have basically lasted forever. They're indestructible. So instead I've installed a DC pump that has this little controller so I can vary the speed, which will be nice during the winter where I really don't need to circulate the water quite as quickly. And instead of the 300 watts, I measured this pump at the same capacity is drawing 84 watts. So over the course of a month, my electric use would be normally $45.10 for that 300 watt pump, and now it's going to be $12.62 a month. Connecticut has some of the highest rates in the nation for electric charges, so it makes a big difference. So overall my savings is $32.47 a month. Annually that's $395 in savings just by using this cheap little DC pump. So essentially this thing could fail every 4 months, and if I had to replace it, it would still be cheaper to do that than it would be to operate that nice high-end industrial commercial pump. Well, I have one leaky fitting in here, and of course it's in a really bad spot because it goes underground. So what I'm going to do is cut it off here, put on a new one which will bring it in a little bit closer, and I'll dig up this pipe and slide it over a little bit so I don't have to cut this and put an extra coupling in here, and then there'll be a coupling in here to extend the pipe so I can keep it pushed up against a wall. It's not really a big deal, but sort of disappointing that I have one failure in all my plumbing work. So I'm going to use a spray bar again to have the water go into the tank, and it serves two purposes: one, to help swirl the water in the tank, and also to help aerate the water a little bit. It's always nice to have a little backup aeration system. For the rest of the standpipe on the slow, I cut this pipe so it's curved and matches with this. Really all it's going to be used for is a support in the center of the bar. I'm just going to plug this in. Support's on there, and that's about all it needs. And on the far end, I'm just going to make a little bracket to help support that end. The overflow drain will get anything off the top of the tank, but I don't want the fish food to come in. So in my other system I had made this baffle that would go onto here, so it would stop any of the surface debris from going down the drain, and really any of the cleaner water comes up through the grate and then up and overflows. However, with this open top, I did have a couple of cases where fish were able to jump up and work their way down the drain. So this time I've made up a little cover that will go over that. And that way, if the bottom of this happened to clog, which it never has in the other one, the water level would rise up a little bit and then overflow this, and so it actually is used as an emergency overflow. So the fish have arrived, and instead of me just dumping them into the tank, I like to count them out and inspect them. So just to support the bag that they're in, put it into this 5-gallon bucket, and then cut off some of the excess plastic so it doesn't get in my way. And then I'll net them one or two at a time into the new tank. Now if this was a established system, or I was buying these from a source that I didn't 100% trust, I would definitely quarantine them. But I've had very good luck with Blackwater Creek and their fish. And I believe they also guarantee that they don't have sick fish, so these are not coming from a pet store or anything like that. That's about it for now. I think that's enough to cover the tank and plumbing. Next up is going to be the radio flow settler. A lot of custom work was put into this one, but it's been working really well, so I hope you stay tuned for that one. Once again, appreciate if you would support us through Patreon. You get to see a lot of exclusive content and early releases to a lot of our videos. Thanks for watching.